Chemistry time. Hello and welcome back to Chemistry Time. Today's discussion will cover a multitude of topics including extensive and intensive properties, units of measurement, and conversion factors. Let's begin with talking about extensive and intensive properties. An extensive property depends on how much matter is present, such as mass and volume, because these values depend on how much you have, whereas intensive properties do not depend on the amount of matter, such as density, melting, or boiling points, because unlike extensive properties, intensive properties do not add. When addressing these types of properties, it is important to take note of the unit because without units, a number is meaningless. The two measurement systems that you probably know are the imperial system, which these are feet, gallons, and pounds, and the metric system, meter, liter, kilogram, etc. We will be using a revised metric system referred to as the International System of Units, which is commonly known as SI units. The base unit of the SI system are as follows, and other units can be derived from these base units. It is important to note that the SI unit for temperature is Kelvin. The conversion from degrees Celsius to Kelvin is by adding 273.15. In addition to these base units, we will also use unit prefixes, which are all based on powers of 10. Some examples of common prefixes are as follows, where each symbol refers to a magnitude such as kilo denoted by the lowercase k and is equal to 10 to the third or 1,000. These multipliers are important and you need to be proficient in using them. A nice little acronym that can be used to help with learning these prefixes is King Henry died by drinking chocolate milk, where the first letter of each word refers to the prefix kilo, hecto, deca. B stands for the base and refers to the SI unit, such as meter, liter, gram. The last three words stand for deci, centi, milli, where kilo is 10 to the third, hecto is 10 to the second, deci is 10 to the first, where with deci, 10 to the negative 1, centi is 10 to the negative second, and milli is 10 to the negative third. We'll be using unit prefixes throughout the remainder of these videos, so it is important that you are proficient in using them. We will do a few examples in a moment to practice them. When dealing with volume, the SI unit can be meter cubed, which is the volume of a cube and is equal to length times width times height, where the metric unit, liters, is more commonly used, which is 1 meter cubed is equal to 1 kiloliter and 1 centimeter cubed is equal to 1 milliliter. We mentioned earlier that density is an intensive property and did not go into detail what it means. Density is the ratio of mass to volume, what can be easily remembered by density is equal to a broken heart. When you mix oil and water, the oil typically floats on top of water because it has a smaller density than water. In addition, density can be used to identify a pure substance because it is a physical property. Let's do an example for calculating density. If we have a 15.32 milliliter sample of benzene, we weigh the sample and determine that it has a mass of 13.4 grams. What is the density of our benzene sample? So looking at our formula for density, all we have to do is divide our mass of 13.4 grams by our volume, which is 15.32 milliliters, and we find that the density of benzene is 0.876 grams per milliliter. It is important to note that the density is an intensive property, meaning no matter how much benzene we have under these conditions, the density will always be 0.876 grams per milliliter. As a review, today we discussed the difference between extensive and intensive properties, the SI unit system, and learned some important conversions and equations. I hope this discussion measured up to your expectations. Until next time, have a wonderful day. Thank you.